Well, there are the different rounding modes, okay, and these let me like we have rounding towards zero, round down, round up, and nearest even. And the challenge that basically we do is the following. Let me discuss in here. So when we have numbers like for rounding, I will talk about the first three rounding modes, which is towards zero, round down, and round up. In this case, if I have a number, like, if you're representing, remember that the rounding can happen depending on basically the precision that we have here. So when I have, for example, imagine, like I have, let's see, imagine, I have 1.5, okay, and I want to round this to integer, okay. Where do you round this? If I have 1.4 and I want to round this to a single integer value, no, okay. If I have 1.4, where do I round it? If I have 1.6, where do I round it? Okay, so that's the question. And like you can have this as, in another case, if I'm just representing one digit beyond the dot, then the same thing will happen if I have, for example, if I have 55 here, or 40, or 14, 45, or 65, okay? Then I will still have, like, I need to, for example, in this case, maybe I will be rounding this to 1.6, okay, maybe I will be rounding this to 1.5 or 4. So this is all basically depends on the mode. And here, one option is round towards zero. In this case, what we say is, if I have a value, and this is like this is in this example, I'm assuming this rounding to the closest kind of like integer value, but I'm just think that this can happen at any level. So in this case, I have this empty circles, which says that anything below, like say in -1 and 0 is rounded to 0. So if it's -1 exactly, then it will be -1. But if it's minus 0.9, then I round it to 0. Okay? And if it's again now 1, then it will be rounded towards 0. If it's, say, for example, 1.5, and then it will be rounded towards 0. So this is rounding towards 0. And the second mode is round down. And in this case, for example, we can talk about, what the mode of rounding when we are doing, let's see, division. Okay, like remember when we are doing a division by shifting left or shifting right, then we had to round it because it was expecting a different. So in the round down case, then this is all the values are rounded down to the value to the left. Okay, and then we have round up, which is you round towards minus plus infinity. Now, in all these cases, why is rounding important? It's round because, since we are rounding at every operation, then imagine you're doing some statistical analysis. And in here, for example, whenever you're rounding towards 0, then you are essentially, changing the standard variance. You're shrinking the data into a short range. If you're rounding down, then you're shifting the mean towards negative. And then if you're rounding up, then the mean is increasing, okay? And these are all important because sometimes you just want to check what the mean is, whether it's 0 or how the standard variance changes, and then you will have these statistical properties changing just due to this round. So the one way to solve this is to round to the nearest even, okay, which is the default mode in this process. And in the nearest even mode is that, each value is rounded to the closest number, but the midway values are rounded to the closest even number. And the nice thing, for example, in this case, what are the even numbers? 0 is an even number, 2 is a now even number, and -2 is an even number. And in these cases, what we do is for example, when we talk about this halfway in between, then I round them to 0. Okay, to the closest one, but not to 1. But if it's 1 point minus 1.5, for example, then I round to not -1, but -2. So with this one, so with this default rounding mode, then the mean and the standard variance is not basically affected. It is affected a bit, but if you're doing this over a large body of data, then you're not introducing any bias into the system. So here we have all these full rounding modes together, and the default one is the nearest even mode. So let's get to this. Basically, let's do some examples. And as I said, default rounding mode, all the others are statistically biased, and we can apply to this to other decimal positions. For example, let's do this. If I have, like, I'm rounding to the nearest 100, so it means that I need to have only 2 digits to the right. Okay. So in here, I have 894999. This is less than halfway, and you round it to 789. Now, if it's greater than halfway, then you round this up, so it becomes 7.90. What about this halfway? Now, this is exactly in the middle. In this case, I look at this, and in this case it's 89,895. Then you round up to 890 because 90 is an even number. So I don't round it there to 79, so 89, but to 90 to make it even. But when you look at 885, okay, which is again halfway, but for a different value. In this case, I round this again to 88, but not 89. So this is basically how rounding to even works when you have this, when you apply it to other decimal places. And this is this works really easy with binary numbers, because what you would a number in a binary fraction number, it's even when the least significant bit is 0, and it's halfway when bits to the right of the rounding position is 1000. Now let's look at this particular example. I have a binary value of 10 point this, okay? And I need to round this to 2 decimal places here. Now, this value here, okay, this is less than 1/2. So you just discard, okay? It's less than half. This one, this is larger than halfway. Again, you just increment it to 0, 1. Really easy. Now, the problem occurs here. This one, okay, this is halfway. Okay? This is exactly halfway. Now, how do I round this? In this case, well, remember, this is alternate, so I want to round this such that I get a 0 in here. So when I round this by 1, you add 1 to here, then you'll get actually 1100. But if I do the same, if I'm in the same position, again, this one is also halfway, but I have an even number here, then it remains the same. Is this clear? So I'll skip this part. I have said, I will leave these slides here, but how to create a floating point number, and in here, should see here, well, I'll just leave this to here.